Today here we are going to have second derivative test to find our local extrema, minimum or maximum. So what is the test here say? So suppose that here you have, suppose x equals c is a critical point, okay? So you have to have critical point at which critical point of f of x, right, at which here your f prime of c equals 0. So what is f prime of c? F prime of c equals 0 means the stationary point. So you have stationary point, so that is what you have. And also assume the second derivative exists. So assume the second derivative here exists, so you are able to get the second derivative. So what is the second derivative here? The second derivative test, they tell you if it turn out your second derivative f double prime at c greater than 0, then the graph of your f of x, the graph of f of x is what? Is concave up. The graph of f of x here is concave up. Okay, so the graph here f of x here just will be f of x here, just trying to see here, graph of f of x is concave up. If the graph is concave up, then your f has local minimum. All right, so what is the second case? The second case here is, all right, I'm just trying to see give a space for myself here. There's not writing. Okay. So here, just try to write the test and then give myself a space here, and then we can just do the whole thing. Okay, so if I return back up here, okay, sorry for this, it's kind of, all right, so here, okay, so if here has local min, what is the case number 2? If you have second derivative is less than 0, then the graph here is what? The graph is concave down. The graph is concave down. If the graph concave down, then what you have? You have local. Then f here has local max. Okay, have local max. What is case number 3? Case number 3, if you have f double prime of c equals 0, then the test point gives no information. No information means we are not able to say there is a minimum or there is no maximum. We are not able. So which means I have to use different tests. I have used different tests in order to say that. So here we require x critical point. If you compare this to the first derivative test, here we compare by we have critical point. It could be in the first derivative test, it could be stationary point, it could be singular point, but here for this test only you have stationary point where your derivative is 0. But for first derivative test you could have singular point, right? So, and then what happened here is you take the second derivative, your second derivative must exist, so you must have in your hand a stationary point, and then you look to the second derivative. If the second derivative is greater than 0, then the graph is concave up, and then you have local min. If the second derivative is less than 0, then the graph is concave down, and then you have local max. All right, so let me give you some example here to apply this one here. So example number 1 here, I need to find, so here use or apply here, so find the critical point. I need to find the critical point, right? The critical point, and classify Classify, what do you mean classify? Classify means you have to find minimum or maximum by using second derivative test, So here we are very specific, we have to use second derivative test. Right, second derivative test. So what is the example here that I give you? F of x equal to x cubed minus 12x squared plus 21x plus 8. So let me call this equation 1. What is my first derivative here? First derivative will be 3x squared minus 24x plus 21. Right, that is our derivative, just normal derivative. And then that is number 2 here, equation 2. Then what do you have for equation number 3? So I could simplify this number 2 here. If I take 3 out, so you have x squared minus 7x plus, if you just plus 7 here, right? So you have 7. If I take 3 out, so you have here 8x, and here you have 7. So I could factor this as 3x minus 1 and x minus 7. Okay, so that is still equation 2 here. So if I give you this one here. After I simplify, I give you this one. The second derivative of x here. If you simplify this, you have 6x minus 24. That is equation number 3. 6x minus 24. All right. So now, what do you need to do in order to apply second derivative test? I must have critical point. So now, guys, if I look at equation number 1, here it's polynomial of degree 3, polynomial of degree 3. If that is polynomial of degree 3, then what is my domain for any polynomial? The domain should be all real numbers, all of them. Why? Because it's a polynomial. It's very nice. If you take x any real number 0, then you are going to get value for f. If you take x 1, any positive number or any negative number, always you are going to get a value for your f. So the domain here, all real numbers. If I look to equation number 2, the derivative here also, it's a polynomial of degree 2. The highest power here, the highest power for x is 2, so that is polynomial of degree 2. So what do I need here? I need to find the critical point. So critical point, I must have in my hand critical point, so especially stationary point. So your derivative f prime is 3x squared minus 24x plus 21. That is, you will have here this derivative here is I have this derivative I have to find related to the derivative. So if I look to the first derivative, it's always exists for any real number x. So why? Because it's a polynomial of degree 2, and that is always exist. So if your derivative always exists for any real number x, means I don't have singular point. No singular point. I don't have singular point because my derivative here always, because you can explain here, because your derivative that I have exists for any real number x, for any real number x. Okay, so that is, so now for any real number x, just for any real number x. So now I have to have x here. I have to have a stationary point. What is a stationary point? A stationary point here, that is where your derivative, stationary point where derivative is 0. So what is the derivative is 0 here? So I have to go, that's the reason I simplify. So you have 3x squared. So you have 3x squared minus 24x plus 21 equals 0. Right? I need to go ahead and solve this one here. If you factor out 3, you have x squared minus 8x plus 7. I can factor this one, or I can use quadratic formula. You can use quadratic formula in order to solve this one here. So that is your quadratic. So you can use quadratic formula here. You can divide by 3, right? And then you can use quadratic formula, or I can factor here. It's very easy to factor. So you have x minus 1 equal 0. X minus 1 equals 0. So now you have to apply 0 product, a multiplied by b equals 0. Then your x minus 7 equals 0. Let's give you x equals 7, x equal 1, x equal negative 1 equals 0, right? X minus 1 equals 0. Then you have x equal 1, this one here, a stationary point. Before I say yes or no, I must check if they are inside the domain. What is my domain? All real numbers, all real numbers, because the domain here all real numbers. So -7 and 1, they are real numbers. Or go ahead and find f, your f, not f prime, f at 1 and also f at 7. So what is your f of x? That is equation number 1. So which means if you go x cube, so you have 1 cube minus 12 1 square plus 21 multiplied by 1 plus 8. So you have to use technology to get the number here. So I got here 18. So that is finite number. So which means 1 inside the domain. Even if you don't know the domain here, f of 1, it will be, it's finite, means 1 inside the domain. F of 7 here, it will be 7 cubed minus 12, 7 square plus 21, 7 plus 8. If I use technology for this, I get minus 90. It's still finite, so 1 and 7, they are inside the domain. So how did I, that's equation 1 here. Look what you have, equation 1. Just replace x here by 1, replace x here by 1, replace x by 1, then replace x by 7, you are get finite number. The reason also you need to get f, the value f at 1 and the value f at 7, because that is your, could be your minimum or it could be your maximum. So now what is the conclusion? What is my stationary point? I have two stationary point. What is the two? X equal 1 and also x equal 7. They are stationary point. They are stationary point. So I have two of them, two stationary point. And then I have to find out the second derivative. Second derivative, that is my second derivative test. What is the second derivative at 1? So I have to go to equation 1, equation 3. Where is equation 3 here? Look what you have here. That is your derivative here. Just replace x by 1. If I replace x by 1, you have 6 minus 24. 6 minus 24. 6 minus 24. So what did you get? You get minus 18, which means derivative. Less than 0. Your second derivative at 1 is less than 0, means the graph is 1, is concave down. The graph is concave down. If the graph is concave down like this, then what you have? You have local max. Local max. So what is the value of your local max? It will be your f at 1. F at 1 here, we'll figure out already. Look what you have. F of 1, 18. That is your f of 1 here, which is 18. So that is your local max, 18. So you have local max at 1 when x equal 1 and your y equal 18. That is the one here, 118. That is the value of your f, the value of your f. Now I need to get second derivative at 7. So I have to go to equation 3, 6 multiplied by 7 minus 24, right? So that is your x. If I replace that 42, so it's very clear it's positive. 42 minus 24. So what you have? You have 18 positive. If the second derivative at the critical point here positive, means your f is concave up. Concave up. Then you have local minimum. You have local minimum. And what is your value? If your local minimum value, it will be f, not f prime or f double prime, just f at 7, which is already, we figure out here, which is, look what you have here, f at 7 here, f at 7, you get minus 90, and that is your local max, local minimum. So your local minimum 7 and minus 90, 7 and minus 90, and that is where you have local min. So let me summarize what I did. Step number 1, you find the critical point or stationary point, and then after you found the stationary point, by taking the derivative, equate that to 0, and then after I took the derivative equals 0, I have to check if the point inside the domain, then they are a stationary point. Then I took the second derivative, I put each critical point at the second derivative, I check if it's concave up or concave down, right? If concave up or concave down, that is where second derivative test. Let me give you example 2. That is, we have, what is, I need to figure out f of x. I need to find and classify, find and classify. What do you mean classify? Classify means if it's a minimum or maximum, right? Find and classify the critical point, your critical point, right? By using second derivative test. By using second derivative test. Second derivative test. right? Second derivative test. So that is what I have, second derivative test. What is your f of x here? Another example here, your f of x, equation 1, x plus 3 multiplied by 2x minus 10 to the power 3. That is equation 1. What is your first derivative? Your first derivative after I simplify, it is 8x plus 1 and 2x minus 10 to the power 2. That is equation 2. What is my second derivative? Your second derivative after I simplify, 48 2x minus 10 and multiply by x minus 1. Alright, 3. So here I'm going to give you the first derivative after I simplify. How did I find the derivative? X plus 3 multiply. When you hear the word multiply by a bracket to the power 3, so you have to apply product rule, but also there is power rules because you have a bracket to the power n. So product rule and power rules, simplify, you get this, and then you get the second derivative. After you get the first one, you are going to apply product rule and also power rule, simplify. If you have difficulty, ask, and you can email me or just come to my office and ask. So that is our second derivative. All right, so now guys, if I look to the equation 1, what is the domain of your f of x? The domain here also all real numbers. Why? Because this one, if you expand, it's a bracket multiplied by itself how many times? 3 times. A bracket multiplied by itself 3 times. So here the highest power for this bracket, x cubed, x to the power 3 multiplied by x, so that is polynomial of degree 4. When I expand the bracket, simplify, you get x to the power 4. It's polynomial. And what is the domain of any polynomial? All real numbers. All real numbers. All right, so how to get step number 1? I need to get the critical point. I need to get the critical point or stationary point. So now, how to get the critical point? No singular point. Why? No singular point. You have to explain that to me. No singular point because your derivative here is, again, it's polynomial. It's a bracket square. If you have a bracket square, means the highest power is 2 multiplied by x. So the total here is x to the power 3, x to the power 3. So that is, your derivative always exists for any real number x. Or let me ask you a question. Is there any value for x? If I put it here in the equation 2, is there any value for x? If I put it here, your derivative does not exist. What do you mean your derivative does not exist? If I use technology, you have error. So if you take x, any real number you wish, if I put it in my derivative, always you get a value for your first derivative, which means your derivative always exists. So I don't have singular point, and then I have to have a stationary point. How to get a stationary point? You take your derivative and equate that to 0. So what is my derivative equation 2? 8. Let's copy from 2 here. 8 multiplied by x plus 1. X plus 1 to x minus 10 square equals 0. So if I divide by 8 here, divide by 8, you have x plus 1 multiplied by 2x minus 10 square equals 0. So now that is called zero product. You have a bracket multiplied by another bracket equals 0. Then it might be the first bracket 0. That is give you x equal negative 1. Second bracket is 0, means your 2x minus 10 equals 0, and then your x equal just 5. You just take negative 10 to the other side and divide by 2, you get 5. So now, what do you have here? You have x negative 1 and 5. Is those two numbers inside the domain? Yes. So what is inside the domain? I have to get f at negative 1, right? F is in equation 1. Here is equation 1, just replace x by negative 1, right? So if I replace x by negative 1, then what you have, just let me give you the number here. So you will have here negative 1 plus 3 multiplied by here 2x, which is negative 2 minus 10 cube. If I use technology for this, you get here 2, and here minus 12 to the power 3, which is, I got here the number that I have, negative 3, 4, 5, 6. It's just a finite number. So now f at 5, I have to get f at 5. If I go to equation 1 here, if I replace x by 5, you get this bracket. 2 multiplied by 5, you get 10. 10 minus 10, you get 0. 0 multiplied by anything, you get 0. So when I replace x by 5, you get here 2 multiplied by 5, which is 10, minus 10, 0. So what I have, I get f of 5, 0. So here, this number, they are finite. And I don't have error when I use technology, means -1 and 5, they are critical point. They are critical point, or they are stationary point, because they are inside the domain. So now I'm going to apply second derivative test. What is second derivative test? By second derivative test, you get the second derivative at -1. So I have to go equation number 3. I just replace equation number 3 here. That is 1 here. And then I have to replace x by -1. X multiplied by -1. What I really care about the sign of your second derivative. What do you mean sign of second derivative? Means is the second derivative at -1 positive or negative? Positive or negative? So that is what I really care. So if I replace x by -1 here, you get negative. -1 with -1, you get negative sign. Here, when I replace x by negative, you get -2 minus 10, you get -12. So negative here, then you get positive, and here positive. So what I really care here, when I replace this one, it turned out it is positive. Then the graph is concave up. If the graph is concave up, then what do you have? You have local minimum. What is the value of your local minimum? It should be f at -1. F at -1, which is the number that I got here, which is, look what you have, f at -1, -3, 4, 5, 6, and that is your local minimum. So your local minimum is 3, 4, 5, 6. That is our minimum, or that is your local minimum. So I replace f at -1. I put it in equation 1 because that is the original one here, equation 1. And I just replace x by -1. You get the number that is our local minimum. That is our local minimum. Okay, so now I have to apply the second derivative test at 5. See, second derivative test at 5, what do you have? Look what you have, second derivative at 5. Here, equation 3, you have 2x minus 10. If I replace x by 5, this bracket, you get here 10 minus 10. If I replace x by 5, 2 multiplied by 5, you get 10, minus 10, you get 0. So the whole thing becomes 0. If one of these 0 multiplied by 48, you get 0. 0 multiplied by anything, you get 0. So here your second derivative is 0, means according to the second derivative test here, test point, no information. No information means I'm not able to say. No information means we are not able to say if there is minimum or there is maximum. I cannot. So we have to use different tests. We have to use different tests in order to say we have minimum or we have maximum. Okay, guys. So that is very much. So summarize what I did. I found the critical point, stationary point. Then I got 2 points, -1 and 5. Then I have to get the value at second derivative at -1. And then if it's positive, then the graph is concave up and we have local min. And if it's negative, then the graph is concave down and you have local max. Here at second derivative at 5, you get 0, means I don't have any information. All right, so let me give you another example here. Example number 3. I need to find and classify by using, what is your f of x? Your f of x here is, just let me give you the derivative here, x squared e to the power -1 over 2x. So that is equation 1. Equation 2, you have f prime of x, which is 1 over 2 x 4 minus x e to the power -1 over 2x. That is equation 2. The second derivative here, equation 3, just 1 over 4 e to the power -1 over 2x, and multiply by 8 minus 8x plus x squared, and that is equation 3. All right, so you have 1, 2, 3. All right, so what is the question? I need to find and classify the critical point by using second derivative test. All right, so now I need to get the domain. What is the first term here? The first term is polynomial of degree 2. What is the domain of any polynomial? The domain of any polynomial should be all real numbers. here you have exponential. What is the domain of any exponential? It should be all real numbers. So I have to look for, if you have a product like this, then the domain should be intersection or overlap between those two. So the domain of the first one, all real number, the domain of the second one, all real numbers, then the domain here should be all real numbers, so which is set of all real numbers like this. So infinity here, so you have infinity, all real numbers, because the domain of any polynomial all real numbers and exponential all real numbers. All right, so that is our domain, minus infinity to plus infinity. Another fact here, just let me write this remark. What is the remark here? You have e to the 1 negative 1 over 2x. It turns out this term here always positive for any real number x, all right. So let me show you here. If it's positive, always, whenever you have exponential function, exponential term like this, it's always positive. Why? What happens if you take x equals 0? Then you have e to the power negative 1 over 2. So you have e to the power 0, which is 1, which is positive. If I take x equal 1, then what you have? You have e to the power negative 1 over 2 multiplied by 1. So you have negative 1 over 2, and that is 1 over e to the power 1 over 2. E here is 2.7. If you try to compute that, you will see it's a positive. Likewise, if I take x here, negative 1, negative number, it will be e to the power negative 1 over 2 multiplied by negative 1. If I simplify that, negative times negative, you get positive. So this one also, it's positive. So now, if you have exponential term, e to the power anything, always just consider it as positive. Okay, so that is something we are going to use from here as a fact, or as something we should really know. So now, guys, how I'm going to apply, what is step number 1? I have to find the critical point. How to get the critical point? The critical point, your derivative f prime of x, which is, just get the derivative, which is 1 over 2 x4 minus x multiplied by e to the power negative 1 over 2x, right? So that is our derivative, that is equation 2. Here, this one, it's always positive, always exists for any real number x. And this one also, it's a polynomial of degree 2, x multiplied by x, you get x squared. X multiplied by x, you get x squared. That is polynomial of degree 2. That is always exist, and this one always exists. So because of that, I don't have singular point, no singular point, right? No singular point. So what do you have? I have to figure out a stationary point. I have to figure out a stationary point, right? A stationary point. How to get a stationary point? Your derivative must be 0. Your derivative must be 0. So you have 0, 1 over 2 x multiplied by 4 minus x e to the 1 negative 1 over 2x, right? So now, how to solve this one? Here 1 over 2, I can divide both sides by 1 over 2. You get 0 equal x multiplied by 4 minus x e to the 1 negative 1 over 2x. What do you know about this one? This term always non-zero, always positive. I show you positive, non-zero. That is what I show you here. It's always positive. Then what you have a bracket. So you have this bracket, so this one on 0. What is you have a product. So you have 0 product. Let me recall that 0 product. What is 0 product here? I have a multiplied by b multiplied by c equals 0. Then your a could be 0, or b could be 0, or c could be 0, or all of them could be 0. All of them could be 0, right? So that is called 0 product. So here you have x could be 0, so I should write here x could be 0, or here 4, what is the second term? 4 minus x equal 0, and let's give you x equal 4, and here you have x equal 0. And so here the question now is 0 and 4 inside the domain. Yes, what is the domain? All real numbers. But also I have to go ahead and find the value f at 0, the value f at 0. So equation 1, where is equation 1 here? Just replace x by 0. If I replace x by 0, what did you get? You get 0 here, 0 square minus, so if I simplify this, you get f of x equals 0 square e to the 1 negative 1 over 2, 0. So that is give you 0, right? So what is f at 4? It will be 4 square That is in equation 1 here. Equation 1, 4 squared e to the 1 negative 1 over 2 multiplied by 4. So you get 16 e to the 1 negative 2. So you get 16 over e square. 16 over e square, right? So you can go ahead and find the number here, 16 over, so which is maybe 0.54. That's a number, whatever it is, so which means 0 inside the domain of your f, 4 inside the domain of your f. So what is the conclusion here? The conclusion here is I figure out the stationary point, that is the one I should have in my hand before I apply second derivative test. So what is your second derivative test? Second derivative at 0. So I have to go equation 3. Here your equation number 3 here, that is your derivative, second derivative here. Go ahead and replace x by 0. What you really care, you should really care about the sign of your second derivative at 0. So here, this one it's a positive, this one always positive. So I'm worried about the bracket here. I'm worried about this bracket here. So how replace x by 0? If I replace x by 0, 0, 0, you get 8. This one positive, this one positive. So you get 0, 0. You get 8, and here positive. So the second derivative at 0 is positive. The second derivative at 0 is positive, means your graph is concave up. Your graph is concave up. If the graph is concave up like this, then what you have local minimum. You have local minimum. How to get the value of your local minimum? F at 0, which is 0. So what is your local minimum? 0, 0. That is where you have local minimum. That is our second derivative test. So now I have to get the second derivative at the second one, which is x equal 4. X equal 4. So I have to go back to equation number 3. Equation number 3 here to figure out the sign of positive or negative. Again, you really care about the bracket here, this bracket, because this 1 over 4 positive, e to the 1 negative 1 over 2x, it's a positive. So I have to replace x by 4. So what do you have? You have 8 minus, if I replace x by 4, you get 32. If I replace x by 4, you get 16. Right? So 8 plus 24, 16, 24, minus, you get negative 8. So negative 8, and here positive. So negative sign here, positive sign here, you get negative. So my second derivative at 4 is negative, which is, so that is negative. Then the graph is concave down. The graph is concave down. If the graph is concave down, then we have local concave down like this. Then you have local max. Local max. And the value of your local max should be the f at 4, which is 16 over e square. So that is your local max. That is our local maximum. All right, guys. So here I figure out 2 stationary points, and then I have to apply second derivative test on each one of them separate to see if it's minimum or it's maximum, and that is the one we call it classify. We call this one classify. All right. Let me give you one example here and finish. Example number 4. You have f of x equal to x cubed ln x. What is your f prime? That is, call it equation 1. Your first derivative here, x squared 3 ln x plus 1, equation 2. Second derivative here, just give it to you, 6x ln x plus 5x. That is equation 3. So what is the question? Find and classify the critical point using second derivative test. Find and classify the critical point using second derivative test. So here I need to find and classify second derivative. Classify the critical point, whatever you have the critical point, right, by second derivative test. Second derivative test. Okay, guys, so let us do that. How did, look what you have, x cubed multiplied by ln x. That is product rule. Then apply product rule, simplify, you get this. And then when I take the second derivative here, that's product rule again. You have to apply product rule twice in order to get this one. Okay, so now I need to find the domain first. Step number 1, I need to get the domain. What is the domain of this one here? Is one or real numbers, but what is the domain of ln x? You see, if you take log here, guys, log 0, you have error. You can use technology here. Log negative number, negative 1, you have error. So which means which means here I have here, which means here, okay, and just I need to get space here. Okay, so which means here, guys, I have to just one by one here. Sorry for this. I just try to. Okay, so which means if you have log something here, x here, whatever you have, then whatever inside. If you take log positive numbers, 1, you get 0, which is okay, finite. If you have log 3 or something, it's okay, positive. You get from your technology, no error, you give you a value, which means log x here, your x must be strictly positive. So whatever inside your log must be greater than 0. Whatever inside your log. So if I have log x minus 2, what is the domain of this? You take always whatever inside, and that is must be greater than 0. Cannot be 0 because log 0 you have error. Cannot be negative. So you have here x minus 2 greater than 0. So what do you have here? X greater than 2. X greater than 2, and that is my domain. X greater than 2, that is our domain. So here, return back to our problem. You have log x. So here you have two function, product of two function. The first one, x cubed, the domain of this, all real numbers. And what is the domain of the second one? X greater than 0, must be x greater than 0. And then I have to look for the overlap between all real numbers and x greater than 0. What is overlap? The overlap here is x greater than 0. The overlap x greater than 0. So what is my domain for this problem for f? Should be x greater than 0. X greater than 0, I could write it as 0 open from 0 here, open to plus infinity. So that is start from after 0, open from 0, because cannot be 0. So 0 to plus infinity. So that is step number 1 to find the domain. So now, what is, do we have singular point? Let me ask you a question. Where is your first derivative does not exist? Your first derivative does not exist at 0, if you have 0, right? But here, log 0, you have error. 0 is not in the domain. So this one does not exist when you have 0, but you cannot have, that is not inside the domain. So here, your domain x greater than 0, if you take any number positive, I put it in my derivative here, take 1 or 2 or 3 or 4 or 5, you'll always you get your derivative here, get value for derivative. So I don't have singular point here because you have to consider any number from the domain, which is x greater than 0, and always you find your derivative, it's always exist, okay? So because of that here, guys, because of that, I don't have, I'm just trying to see you. So because of that, no singular point. So I have to go ahead and find stationary point. How to get stationary point? So that is your derivative equals that to 0. What is my derivative here? I'm just simplify. It would be x squared 3 ln x plus 1 ln x here plus 1. That is should be 0. Right, so now what do you know about x squared? Your x here is what? Greater than 0. So x squared here is positive and non-zero. So which means 3 ln x plus 1 equals 0. Because this one is non-zero, then the bracket here, this one should be 0, because you have a product here, a multiplied by b equals 0. If a non-zero, then b must be 0. b must be 0. At least one of these must be 0. So here, how to solve this one? 3 ln x, take 1 to the other side. You must have here 1, so ln x equal negative 1/3. How to solve this one? You have to recall here, guys. You have to recall log b of x equal y. Then it will be b to the power y equal to x. b to the power y equal to x. b to the power y equal to x. So here ln x equal negative 1/3, and then that is log base e. ln here it's log base e of x equal negative 1/3. What is the equivalent? That is your b. It will be e to the power negative 1/3. e to the power negative 1/3 equal to whatever inside here, which is x. All right. So that is our. Is this one here inside the domain? Yes. Is this what is x equal e to the power negative 1/3 is 1 over e to the power 1/3. If you use technology here, 2.7 to the power 1/3. It's a positive number, so your domain x greater than 0. That's our domain. So yes, this number inside the domain. So that is our stationary point. So do we have a stationary point? Yes, I have a stationary point. If you want, I can get the number here. Also f at e to the power -1/3. Right? So the value f, if you don't know the domain. So I have to go equation 1 and replace x by e to the power -1/3. Where is equation 1? Here. That is, go ahead and replace x by -1/3, and then you get the value. You can use technology for this. So you have e to the power -1/3 to the power 3 ln e to the power -1/3. That is your x here. That is my x. So you have x cubed ln x. That is your f of x. So I have to replace x by e to the power -1/3. Simplify this, you get your f at e -1/3, right? So that is, I need to get the value. This one, it will be e to the power -1. This one, it will be -1/3. That is your e to the power r. It will be ln e, which is 1, right? So what did you get here? You get -1/3, and here e to the power -1, which is -1/3, 1 over e. So here you can do it like I'm doing here, or just use technology one step, like this one here. You can use technology here, and whatever the number here is, you just write it. So what I really care, this number is finite number, so which means it will be inside your domain, okay? So if I simplify this, then what you have, you could have here whatever the number here is, that is your it will be minimum or maximum. So now let me summarize what I did here so far. I took the derivative, equate that to 0. Here I know x greater than 0, so x squared, it's a non-zero, then this bracket is 0. I have to recall log base b of x equal y, then that is your b, which is base, that is my base b to the power y equal x, and then I have to go ahead and use technology to find this one, which is, you get -0.1. So now I use technology to get this one here. So I have to apply second derivative test, which means second derivative at e to the power -1/3. So that is equation number 3, right? In order to see if it's positive or it's negative, so I have to go equation number 3. Where is equation number 3? Here. Go ahead and replace x by e to the power -1/3. Okay, so here, what is the second derivative? Just let me write it for you so that you can see. The second derivative here is, I'm copy that. So it's second derivative 6x ln x plus 5x, right? So what do you have? It will be 6. If I factor out x, if I take x out, then you have 6 ln x plus 5. And then what is your x? E to the power -1/3. That is your f at e to the second derivative. I need to get the sign, it's positive or negative. And here what you have, 6 ln e to the power -1/3, right? And here plus 5. Close the bracket here, right? What do you know about this term? This one, it's a positive. Always this one positive. So I really care about this, the sign of this. So how to use, if you have log e to the power r like this, it will be r log a. So here -1/3. So what do you have? E to the power -1/3, open bracket, 6 -1/3 ln e plus 5. This one here is 1. 6 multiplied by -1/3, you get -2. -2 plus 5. And here e to the power -1/3. So what do you get? You get 3 e to the power -1/3. So it's very clear this one positive. So if your second derivative at this number here is positive, greater than 0, then the graph is concave up. The graph is concave up. If the graph is concave up, means you have local what? Concave up like this, then you have local minimum. Local minimum, how to get the local minimum? The value f, not f prime, not f double prime, at e to the power -1/3. Already I found that here. Look what you have here. That is the one here, f at this one here. So that is your local minimum. -1 negative 1 over 3 multiplied by e. So negative 1 over 3, if you try to use that, negative 1 over 3 multiplied by e, whatever the number here is, that is our local min. That is our local min. Okay, guys? So here, it's very important to know the domain of your log. You take whatever inside your log should be greater than 0. Here, in our case, x. So your x must be greater than 0. And then, if you know the domain x greater than 0, then I have to consider that on my stationary point to check if they are inside the domain or outside the domain. Okay, guys? All right. So I think I will stop here. So that is our second derivative test. Thank you. I'll see you next time.